Today I'll be reviewing the practice midterm exam, problems 8 to 14. So starting with number 8, we're told to solve the problem, and the table, problem 8 states the table below shows the number of people testing positive for a certain disease amongst those who do have the disease and amongst those who don't. Use the table to answer the question. So we have a table with columns test positive, test negative, and total. And then we have rows for those with disease, those with no disease, and the total. So what percentage of those that tested positive actually have the disease? Okay, so here we are looking for two different things. We want individuals that tested positive, so that's that column here, and we want individuals that have the disease, and that is this row here. So the individuals that test positive and have the disease are 111 people. So to write that out, test positive with disease over the total that test positive is, so we identified 111 test positive with the disease, and the total that test positive is 1,181, okay? And we're going to multiply this number by 100% so we can get a percentage. This asks for what percentage? So that will be approximately 9.4%. And that's our final answer for problem 8. So next we have problem 9 says to use the compound interest formula to determine the accumulated balance after the stated period. So we have $2,500 deposit at an APR of 3% with monthly compounding for 5 years. So for this problem, this is actually very similar to an example from Unit 3B. So from your textbook, Unit 3B, example number 5 on page 206. So this is a good reference for you. Okay, so for this problem, we are going to want to use the following formula. A equals P, the principal amount, times 1 plus APR over N to the power of N times Y. Okay, and here in the original problem, it's important to note that we have monthly compounding. So that's why we use this formula as opposed to a different formula. So we know that the interest is going to be paid 12 times a year. So N is going to be 12. And we are considering a period of Y as 5 years. And we know that the principal amount, P, is going to be the initial deposit of $2,500. And our APR is given at 3%. And we want that in decimal format. So to change a percentage from decimal, you can move the decimal point either 2 places to the left. So it becomes 0.03. Or you can divide by 100, and you will also get the decimal of 0.03. So that's our APR. So these are our known or given values. So this is what we know, this is what we're given, and we want to find A, the accumulated balance. Okay, so now we can substitute what we know into our formula. So again, we're going to plug in the values that we know. So our principal amount was $2,500 times 1 plus our APR 0.03 over N, which we determined was 12, because it's monthly compounding, to the power of 12 times y, which we identified as a period of 5 years, right? And from here, before you plug it into your calculator, it's actually easier to simplify what you can. So in parentheses, you'd plug in 1 plus 0.03 over 12, and you'd see that you get 1.0025, and we get to the power of 12 times 5 is 60. So from here, it's a lot easier to plug this into your calculator. And so you round to the nearest cent, and you get $2,904.04. So that's our accumulated balance for problem 9. All right, so moving along to problem 10, we have used the compound interest formula for continuous compounding to determine the accumulated balance after the stated period. So problem 10 states a $36,720 deposit in an account with an APR of 3.6% compounded continuously for 10 years. So again, another similar problem to this problem is from Unit 3B. The formula is on, first though, the formula is on page 209. And a similar example is number 7 on page 210. Okay, so the formula that we're going to use is the following. We have A, our accumulated balance, is equal to P, the principal amount, times E to the power of APR times Y. So, and I just want to note that for those of you who are not aware yet, the number E is a special irrational number with the value of, so to the side, E is approximately 2.71828. But you can actually find this on your calculator. You can use the key that looks like this, e to the power of x. So you can use this key on your calculator, e to the power of x, to compute any problems that you may come across. So you don't have to use this, but this is just for reference. All right, so we know that our principal is $36,720. Right, this is our P. Our APR of 3.6%. 3.6% gets converted to a decimal, so remember you can divide that by 100, or you can move the decimal point 2 places to the left. But this becomes 0.036, and then we're told that it's compounded continuously for 10 years. So Y is 10. Okay, so we're going to substitute what we know, and I'm actually going to remove all of that so that we have more space. All right, so E APR is 0.036 times Y at 10. And from here, again, try to simplify before you plug everything into your calculator. So when you plug in 0.036 times 10, you get 0.36. Okay, and then from here you can plug everything into your calculator, and you will get $52,631.86. So that's problem number 10. Okay, for problem 11, we're told to find the annual percentage yield, APY. So this is different than APR, so don't get these two values confused. Oh, sorry about that, that's my alarm. So we have a bank offers an APR of 2.1% compounded monthly. So for reference from the textbook, this is also from Unit 3B. You'll see a pattern. Most of the problems that we're reviewing are from Unit 3B. So if you haven't already, this is a good section to review. I know you guys have homework problems for this section as well, so those are also very helpful. But for reference, you can review pages 206 and 208. And this is very similar to example number 6 on page 208. Okay. So first you'll want to find balance at end of 1 year and assign a principal amount. But from here, to find the balance at the end of 1 year, you'll want to use the following formula. So we have A equals C times 1 plus APR over N to the power of N times Y. Right? So this is that formula that we used for problem 9. Okay, and so we're going to plug in what we know. Don't have a principal amount, so we can assign the principal amount at $1,000. So you want to keep it simple. So we have the principal amount of $1,000 times 1 plus an APR of 2.1%. That needs to be changed to a decimal. So it becomes 0.021 over N. So we're told that it's compounded monthly. So if it's compounded monthly, that means you pay once a month, 12 times a year, right? So N is going to be 12. And here we have N, so 12 times Y. So Y is going to be 1 because we want to find the balance at the end of 1 year. And from here, you'll want to simplify before you plug everything into your calculator. So we get 1.00175 to the power of 12. And from here, it's very easy to plug this into your calculator. And so you should get $1,021.20. So this is our accumulated balance at the end of 1 year that we assigned a principal amount to. Remember, it's important to note that the original problem states to find the annual percentage yield. So that's different from the accumulated balance. So we can't stop there. We actually have to keep going. So second step for this problem, you want to note how much the balance increases by. So we have an accumulated balance. We want to subtract that accumulated balance, our principal amount, and we get the following. So we have $1,021.28 minus our principal amount of $1,000, and we'll get a balance of $21.20. So we can see that we'll see that we get an increased balance of $21.20. So from here, we can solve for the annual percentage yield. Okay, so the annual percentage yield, basic definition is that it's a relative increase in 1 year. Hence, wanting to find an accumulated balance at the end of 1 year in step 1. So for our annual percentage yield, we can put our balance increase of $21.20 over our principal amount of $1,000, multiply that by 100%, and we can get our annual percentage yield of 2.12%. So we have an annual percentage yield of 2.12%. Okay, so I know this problem is a little complex since it's a two-part problem. So it's really important to pay attention to detail. Okay, so for problem 12, we're told to solve the problem, and it states you want to have a $50,000 college fund in 10 years. How much will you have to deposit now in an account with an APR of 4.4% and quarterly compounding? Assume that you make no deposits into the account after your initial deposit. Okay, so this is a very complex problem. There's a lot of different parts. For reference, you'll want to refer to page 206 from Unit 3B. And okay, we're going to want to identify what we know and what's given. Okay, so we're told that we want a $50,000 college fund. So this is something that we want. This is not something that we have, right? This is not a principal amount. Rather, this is an accumulated balance. So this is going to be A. We want it in 10 years, so that's going to be our period of time, Y, right? We're also told that we have an APR of 4.4%. So we're given an accumulated balance of $50,000. We have an APR of 4.4%, and you have to change that to decimal format. So again, either divide by 100 or move the decimal place 2 places to the left, and you'll get 0.044. We know that N, okay, so we were just getting to this, but N is right here, quarterly compounding. So quarterly, there are 4 quarters in a year, right? And so we would pay 4 times a year. Okay, so quarterly compounding, N is 4, and Y, our period, is going to be 10. We are asked, how much will you have to deposit now in an account with an APR of 4.4% and quarterly compounding? So deposit now. Okay, this is our principal amount. That's what we're missing. So we need our principal amount. We need P, the amount that we need to deposit now. Okay, so for these types of problems, it's really important to identify what you know or what's given and what you need before you even try attempting to identify what formula you need to use, because this way it actually narrows that down for you. And so we have the accumulated balance, we have an APR, we have N, we have Y, we know that we need the principal amount. So for this, we know that it's going to be a compound interest formula, right? Because we're told that there's quarterly compounding. So it's going to be the compound interest formula for interest paid n times per year. And this is on page 206. Okay. So this is a formula that we've used before in problems past, except for the slight challenge that this formula solves for the accumulated balance, right? So we have an accumulated balance equals P, the principal amount, times 1 plus APR over N to the power of N times Y. Okay, and so from here, since we're solving for P, the principal amount, we're actually going to want to rearrange the problem so that we can solve for P. So to do that, we want to divide by 1 plus APR over N to the power of N times Y. And we want to divide that on both sides. We divide by this on both sides, and we see that this will cancel out on the right-hand side. And so what we're left with is P equals A, the accumulated balance, over 1 plus APR over N to the power of N times Y. Okay? So this is how you would rearrange the problem to solve for P, the principal amount. This is the same formula. It's the compound interest formula for interest paid n times per year. So from here, we can actually substitute what we know. And again, for a refresher, these are all the different values that we identified, and we're now going to substitute what we know into our newly restructured formula. Same formula, just solving for P, the principal amount. Okay, so our accumulated balance is $50,000 over 1 plus an APR of 0.044. N we identified as 4 because it's compounded quarterly. And so we have N to the power of N times Y. So we have 4 times Y as 10. And then from here, again, you'll want to simplify before plugging this into your calculator. So the bottom simplifies, the denominator simplifies to 1.011 to the power of 40. And then from here, the principal amount is approximately $32,279.28. So that's our principal amount for problem 12. All right, so we're going to wrap up this session with problems 13 and 14. So problem 13 states, Stephen sets up an IRA with an APR of 4% at age 26. At the end of each month, he deposits $84 in the account. How much will the IRA contain when he reaches 65? Compare that amount to the total amount of deposits made over the time period. So again, this problem is adapted from Unit 3B. The formula is on page 218, and the example that it is similar to is example number 2, which is on page 220. So we're going to want to identify what we are given or what we know. So we know that the APR is 4%, And when changed to a decimal, it's 0.04. We have a new variable, but our PMT is $84, right? Because it says he deposits $84 in the account at the end of each month. So that's our PMT, and at the end of each month, that's our how many times he deposits in a year. So N is going to be 12, and Y, the period, is going to be the difference in his ages. So we want to know how much this account will contain when he reaches 65. He is currently 26 years old, so our period is going to be the difference between his ages. So 65 minus 26, we get 39. So our period is going to be 39 years. And we need to solve for A, the accumulated balance, because we want to know how much his account will have when he reaches 65, right? So from here, this is a different formula that we have not used yet. It's on page 218. Again, this is very similar to the example on page 220, so you can refer to that. But we are going to use the following formula. So we'll solve for the accumulated balance with this formula. So PMT times 1 plus APR over N to the power of N times Y minus 1 over APR. Okay, and we are going to substitute what we are given into the formula. So I'm not going to rewrite the formula, but our PMT was $84. That's the amount that he deposited per month. And in the numerator, we have 1 plus APR over N. So APR we identified as 0.04 because APR is at 4%, right? N is 12 because that's the number of times that he deposited per year. And then that was to the power of N times Y. So that's 12 times 39 minus 1. And then this was all over APR over N. So again, APR is 0.04 and N is 12. Okay? And after you plug this into your calculator or simplify to the nearest cent, you'll see that the accumulated balance of his IRA at 65 is $94,411.59. So that's half of the problem that we are asked to solve. However, looking back at the original problem, we're also told to compare that amount to the total amount of deposits made over the time period. So we found his accumulated balance at 65. We now need to find the total amount of deposits made over 39 years. So the total amount of deposits is, so in order to figure out the number of total deposits during that period, we'll want to multiply 12, so that's the amount of deposits per year, by the period. So that's 39 deposits multiplied by $84 over deposits. Okay, so another way to think about this is N multiplied by Y. So in order to find the total amount of deposits, you multiply n by y to find the total number of deposits, and then multiply that by the amount that he deposits. So amount over deposits, right? And this will equal $39,312. So that's the total amount that he deposited. And this is the accumulated balance. Okay, so we want to compare the amount to the total amount of deposits made over that time period. And so to do that, we are going to take the difference of the two. So you'd take A subtracted by the total amount of deposits, and we would get, so again, A is $94,411.59, and then the total amount of deposits is $39,312. So we get $55,099.59. So we know that the balance, the accumulated balance, $55,099.59, more than total amount of deposits. So this is the second half of your problem. So you'll see that there are two different steps. You'd have to solve for the accumulated balance, and then you solve for the total amount of deposits here, and then you take the difference of the two values, and the difference is going to be the comparison between your accumulated balance and the total amount of deposits. Okay, and lastly, for problem 14, you intend to create a college fund for your baby. If you can get an APR of 3% and want the fund to have a value of $143,922 after 18 years, how much should you deposit monthly? So again, this is adapted from the textbook. It is from Unit 3B, and it's similar to example number 3 on pages 220 to 221. And first, we are going to want to identify what we're given. So we have an accumulated balance. They want the fund to have a value of $143,922. Okay, so that's our accumulated balance. Y, the number of years, the period, is 18. We have an APR of 3%. So change to decimal, it's 0.03. We have N, because we're asked how much should you deposit monthly. So monthly, meaning once a month for a year, so that's 12 months. So that's 12 times that you would deposit per year. Okay, so that's everything that we're given and that we know. And we're asked to solve for PMT. So this is really similar to the example on pages 220 to 221. And we are going to want to use the following formula. But this has been rearranged to solve for PMT. I'm not going to show you how to rearrange the original savings plan formula, but if you want to see the steps, you can find that in the textbook or on pages 220 to 221. But by having the rearranged problem, this will save you time. So that's the formula that's been rearranged to solve for PMT. Okay, and so we are going to, again, substitute what we know into the original formula. So A is our accumulated balance at $143.922. We're going to multiply that by APR over N for the numerator. So APR is at 3%, that's 0.03. N, it's 12 because she's making monthly deposits over, we have 1 plus APR again over N multiplied by to the power of N times Y. So N is 12. Oops, and I forgot to substitute N for 12. Okay, times 18. Kind of running out of room. Alright, so we have to the power of N times Y, so that's 12 times 18, and minus 1 from our formula. Okay, and then we're going to want to simplify this before we plug it into our calculator. So 0.03 over 12 becomes 0.0025 over 1.0025 to the power of 216 minus 1. And we get a PMT of $503.33. So that is everything that we are asked for this problem. So if you have any questions, feel free to use the discussion boards and or email.